Hello guys, and welcome to another video from Lenjval Technologies. Today we are going to continue our series on algorithms. Before we start our video, our lesson, let us click that subscribe button. Remember to like our videos and share them with your friends. Give a very big shout out to one of our producers, Ajong. He's doing a very great job there with our videos on that programming with C. And another shout out to one of our other producer, Mahatma, who is doing a great job there with our videos on Microsoft Access. We want to encourage you, all students who are preparing for their exams, especially in this crisis moments, who are unable to go to school. May you check out those videos, and they're going to be of great help for you, especially as you prepare for the practical session of your exams in computer science. May we dive in straight to our video. So today we are going to be dealing with algorithm strategies. So what is basically an algorithm strategy? An algorithm strategy is a general approach to solve problems algorithmically. A general approach to solve problems using algorithms, if I should put it that way. Although more than one technique may be applicable to a specific problem, it is often the case that an algorithm constructed by one approach is clearly superior to equal solutions built using alternative techniques. So let's get some examples of algorithmic strategies. I'm going to list down those which we are going to touch in this particular lesson, then we are going to treat them one after the other. So we have brute force algorithms, we have greedy algorithms, which is like to say take what you can get now strategy. Then we have the divide and conquer algorithm. Then we have the transform and conquer algorithm. Number one, brute force algorithm. So with brute force algorithms, we are talking about a straightforward approach to solving problems. And using this method, it is usually based on the problem statement and definition of the concepts involved. It's one of the easiest approaches in solving problems, or one of the easiest approaches to apply when solving problems that have to do with algorithms, and it is very useful to solve small size instances of a particular problem. So some examples of brute force algorithms are maybe computing a mathematical problem such as a to the n. You will see that on your screen there, where a is greater than 0 and n is a non-negative integer. So that's simply an example of brute force algorithm. Also, computing n factorial, selection sort, bubble sort, sequential search, which we are all going to see in our subsequent videos. The second kind of algorithm which we're going to talk about are greedy algorithms. As I earlier said, it is take what you can get now strategy. Why so? Because the solution is being constructed through a sequence of steps, each expanding a partially constructed solution obtained so far. At each step, the choice must be locally optimal. Some examples include a minimal spanning tree, short distances in graphs. Don't mind if you don't know the meaning of these big terms. We are going to break those as we move further with our as we get further in the lessons. The next one we are going to talk about are divide and conquer algorithms. We could also call this stepwise refinement, as these are methods of designing algorithms which have a particular pattern. Given the instance of the problem to be solved, you split this into smaller sub-instances of the same problem. Remember this. Independently solve all the sub-instances and then combine the sub-instance solutions so as to yield a solution for the original instance. You have a given problem, you divide it into smaller sub-problems, then you solve those sub-problems separately, then you bring together their solutions in order to get the solution of the original problem which you have. So we are going to give you some examples of divide and conquer algorithms, which include computing a to the n by recursion, binary search in a sorted array still by recursion, merging algorithms, quicksort algorithms. So the fourth type of algorithmic strategy we'll talk about here is the transform and conquer. Sometimes people get to confuse the difference between divide and conquer, decrease and conquer, and transform and conquer. Now, with transform and conquer, it works as a two-stage procedure. First, the problem is modified to be more amendable to a solution, and in the second stage, the problem is solved. Listen, the method works in two stages. The problem is first modified to be more amendable to solution, and in the second stage, the problem is being solved. Some examples include just consider the problem of finding the two closest numbers in an array of a list. You can use transform and conquer algorithm here to solve a problem like that. Don't mind us not going into details of these examples which we are giving, because we are going to have them in the subsequent lessons, but we are going to leave footnotes at the end of the video or in the description area so you can go check out more about those examples. Now let's get up to something else. Design approaches. These are the different approaches which we use to design or to build an algorithm. We're going to focus on two here: top-down design, excuse me, and bottom-up design. The top-down design or top-down approach is you are essentially breaking down a problem to gain insight into compositional sub-problems. This top-down technique kind of logically progresses from the initial instance down to the smallest sub-instance through intermediate sub-instances. While with the bottom-up design, it's simply the reverse of the top-down design. You understand? You just simply have to, the smallest sub-instances are explicitly solved first, and the results of these instances are brought together to construct solutions to progressively larger sub-instances. Now, the second thing I would like us to talk about today is recursion. I think it's a very, very important concept for you to grasp when talking about algorithms. Now, a recursive function is a function that calls itself during its execution. A recursive function is a function that calls itself during its execution. The main characteristics of a recursive algorithms are these. Here means it specifies the situation when the result can be obtained directly without the need of a recursive call. While recursive call, the algorithm calls itself at least once. That is the value of the parameter corresponding to a cascade of calls should lead eventually to the stopping condition. Now we are going to take a particular example of a recursive function. Now we know in general problems that are defined in terms of themselves are good candidates for recursive techniques. The standard example used by many computer science textbooks is a factorial function. Okay, now let's consider the problem of computing n factorial, right? Let n be a natural number. Starting from the definition of n factorial equals to n times n minus 1 times n minus 2 times right up to 1, and applying the brute force technique, also known as the iterative technique, take note of that, we obtain the following algorithm, which you'll find on your screen right now. You now see why factorial is often the recursion, because it is defined in terms of itself. That is, taking the factorial of n, we have n factorial is n times n minus 1 factorial. N minus 1 factorial equals n minus 1 times n minus 2 right up to 1. And what did we have as n factorial? It was n times n minus 1 right up to n minus 2, n minus 3 till 1. So if we extract n from the problem, what we have left is n minus 1 factorial. So basically n factorial is the same as multiplying n by n minus 1 factorial. So let's try now how to write our factorial function. You can pause it in order for you to copy it, or to see what else, to see how else you can do it, and you can propose to us better means of doing it when you discover one. I think that's the purpose of watching these videos and learning about creating. It's about getting new ideas and doing things better. Okay, we have come to the end of this video. In the next video footnote, we are going to leave you many other examples of recursive functions so you can work on in order to improve your recursive skills. This include the Fibonacci sequence, the power function, and the very popular one, the Hanoi tower. Thank you for watching this video, and don't forget to share, like, and subscribe. Thank you.